Hello everyone, today we're going to talk about the database design. I will explain you how to translate your client requirements into the database architecture. I'm Andrei from Digiterry, let's begin. As you remember from the previous video, your client wants to start a car sharing business. You talked to a client Acme and collected the following requirements. Every traveler can register on the website using her email address. Once registered, the user should verify her email address in order to start using the website. A user may specify contact email and phone number. Users may have several phone numbers. Every phone number should be verified via SMS. The user should type in a verification code sent to her number. Users may publish information about the planned trip: origin and destination place, travel date, number of empty seats, how long the trip takes, price for one seat, currency. The trip should expire after the travel date. Each place can be identified by its latitude, longitude, and the country. For every place, the language should be stored in the system. That will be used in Google search. Users may send internal messages to each other regarding the trip. All countries should be stored in the database. For each country, it should store the latitude, the longitude, and the phone code of the country. All currencies should be stored in the database along with the currency codes and size, for example, the dollar sign. That's all requirements that you have collected from the client. Sounds great, but what does it mean for our database architecture? Let's analyze the requirements step by step and extract useful information from each sentence. Every traveler can register on the website using her email address. It means that we should have an entity traveler or user in our database with the email address property. The user should verify her email address in order to start using the website. It means that each user has at least two states: unverified and verified. Additionally, we should store the verification code in the database. A user may specify contact email and phone number. Those are another two properties of the user entity to let other users contact our traveler. Normally, this information is enough to start building your database architecture. Each entity corresponds to a table in the database, and every property corresponds to columns. For the rest of the video, I will be using my SQL workbench to illustrate how client requirements are translated into the database. In the normal development process, you should create database and all objects respectively, including tables, stored procedures, and functions. But I will save this time by providing you with a script, which you can find attached to this video. We select the script and execute it. Okay, it's done. We refresh the area and now we can see our Acme database with all entities, means tables, and their respective columns. In order to understand how client requirements have been translated into specific objects, we use reverse engineering. We go to Database and click on Reverse Engineering. Next, we select the Acme database. And it's done. Now we can see a very nice representation of our database, along with the tables, connections between tables, properties, indexes, and so on. Let's go back to our first requirement. Every traveler, means user, can register on the website using her email address. Once registered, the user should verify her email address, means two states, verified and unverified, and two additional properties: contact email and contact phone number. When we take a look at the database and locate the user entity, we can see that each user has a username, email, a password, status, showing whether this user entity is verified or unverified, contact email and contact phone number to let other users contact, and we have a created and updated, which has timestamps. I would like to draw attention specifically to the data types. As you can see, varchar 60 is selected for the unique identifier of the user. Varchar means a symbolic string containing 60 symbols. As a status, we take tiny int of 4. At the contact email, there are bits indicating that the contact email or contact phone number are visible to other users. For created and updated, we selected a timestamp showing the exact date and time when the user record was created or updated, respectively. Let's take a closer look at the second requirement. User may have several phone numbers. Users and phone numbers. Every phone number should be verified via SMS. Should be verified. The user should type in a verification code sent to her number. Which information or which database objects we can derive from the specific client requirements. The user entity we already have in our database. Now we have phone numbers. The users may have several phone numbers. It means one-to-many connection between user and phone number entity. Every phone number should be verified via SMS. Once again, we have two states for the phone number, verified and unverified. The user should type in a verification code sent to her number. All over again, we need a verification code stored in the database, which was used to verify this specific phone number. Let's see how the second client requirement is translated into the database design. We switch back to MySQL Workbench and locate our phone number entity. I will put it next to user to understand the connection. So each entity phone number, which is represented by the table in the database, has the following columns. User ID, which uniquely connects each phone number to the user. Since we have user ID column in the phone number, then the user could have several phone numbers respectively. That's very important because the connection between user and phone number is one-to-many. Then we have a country ID in order to connect the phone number to a specific country. That will be useful for the future when we have different phone numbers with the different country codes. We have a number, obviously, a verification code. If you remember, each phone number should be verified. Then we have a verified column at the type of bit, which means 0 or 1, verified or 1 unverified. We have another column, active, which is to indicate that the phone number is active or not. And we have a created timestamp. The column which contains the exact date and time when the phone number record is created. Let's move next to the third requirement. Users may publish information about their planned trip, origin and destination place, travel date, number of empty seats, how long the trip takes, price for one seat, currency. And one more requirement, the trip should expire after the travel date. The third requirement implies that we should have a trip entity in the database, which has links to two places, origin and destination. It makes sense to create one more entity, place, which contains the geographical coordinates, latitude and longitude of the places where the trip starts from and where it goes to. Travel date, the property of the trip. Number of empty seats is also a number, a property of a trip. How long, the number of hours, price for one seat, and currency. Since we could have multiple currencies in the database, it means that we should create an additional entity in the database named currency, which will be connected to the specific trip. The trip should expire after the travel date. The expiration means the state change between non-expired and expired travel date. Accordingly, we create one more property of the trip entity, a column status, which will indicate whether the trip expired or not. Fine, let's take a look how this particular requirement is implemented on the database level. Let's navigate to the trip entity in the MySQL workbench. The trip entity has the following columns: ID, a unique identifier, a user ID is a connection to the user entity. This connection is one-to-many. One user could have many trips. Then we have from and to columns, which are connection to the place entity respectively. We have date, number of seats, duration, and price as stated in the client requirements. The column currency ID represents the link to the currency table. The column status tells us whether the trip has expired or not. The created and updated columns tells us when the trip was created and when it was updated the last time. The place entity contains all the information about specific location, whether it's the origin or destination place. Accordingly, it has a place ID, a unique identifier, the latitude and longitude, the country code, and East country flag. The East country flag tells whether the place was specified as a country without a city. It's the case when the destination location is too small. Let's say it's a small country and it's enough to tell that the destination is a country without telling which city it is. The place entity is connected to the place length. On this level, we start to think about the UI implementation. Since we will be using Google Search, we enable user to enter the place in any languages he wants. Hence, we should have language stored in the database. The place and place length entities, which I have described, cover the requirements number 4. Let's go to the last page of requirements and analyze how to implement it on the database level. Users may send internal messages to each other regarding the trip. Obvious that internal message should be an entity in the database. The internal message has at least 2 connections, to the user who sent it and to the user who will receive it. Additionally, each message should have a link to the trip, since every message relates to a trip. Let's take a look what we have in the database. The message, I will move it over there, has a connection to the trip respectively. We can see it by the column trip ID, and it has a connection to 2 users, from user ID and to user ID. Those 2 fields are foreign keys to the user, representing the links to the user entities. Additionally, the message entity has a text, which is the most important part, and it has a created timestamp. Let's take a look at the last 2 requirements. All countries should be stored in the database. For each country, it should store the latitude, longitude, and the phone code. And the last requirement, all currencies should be stored in the database along with the currency codes and signs. Let's take a closer look how those two requirements are implemented in the database. First, we take a look at the country. The country table has the code columns, name, phone code, latitude and longitude, as described in the client requirement. The currency table has code and sign format to show the currency sign. That's all for today. Now that you know how to derive the database design from the client requirements, you can use this knowledge effectively on all your E2 projects. Thank you very much and see you next time.